A very good afternoon, everyone, and welcome back to the second day of the Autocar Professional Vehicle Lightweighting Conference, an annual 2-day event that aims to spark relevant conversations around the important topic of lightweighting. As the automotive sector undergoes a transformative shift towards electric and hybrid vehicles, reducing vehicle weight has become paramount for optimizing energy consumption and extending the battery range. Moreover, OEMs are also pushing the envelope to stretch every ounce of the costly fuel when it comes to enhancing the efficiency of conventional ICE vehicles. So, optimizing vehicle weight is one mantra for sustainability, and lightweighting has emerged as a crucial trend in the automotive industry due to its profound impact on various aspects of vehicle performance, efficiency, and sustainability. My name is Mayank Dhengra, and I'm the Assistant Editor for Autocar Professional. And I'll give you a quick recap. Yesterday, we touched upon the key drivers and challenges of lightweighting, including regulatory requirements that are driving the industry towards adopting the lightweighting methodology, and some of the supply chain constraints related to the advanced materials like the unavailability of ultra high strength steel and high strength steel in India. So today in this panel discussion, we have an eminent panel that we have with us. And over the course of the day, we'll have two sessions. The first, we have the panel discussion, and after that, we have a one-on-one interview. So we hope that you enjoy both the sessions and you have a lot of takeaways from them. And I'll quickly begin with the first session, which is the panel discussion. And I'll start to introducing my eminent panelists. We have Mr. Glyn Jones, the MD of Gistamp India, based out of Pune. Mr. Ivy Rao, who needs no introduction, the former engineering head of India's largest car maker, Maruti Suzuki India. Dr. K. Subramanian, the senior vice president at Ashok Leyland. John Johnson, chief engineer, body structures at Tata Technologies. And lastly, Rahul Nikhanj, head projects and production technology, Asahi India Glass, which is the largest glass supplier to Indian OEMs. So today's topic is advanced materials, design and manufacturing techniques in automotive for lightweighting. And we'll begin this panel with a quick comment from each one of you. And I'll like to begin with you, Rao-san. Your broad thoughts on, why lightweighting is important and, what are the key requirements that are pushing the industry towards adopting lightweighting strategies.
Yeah, thank you, Ms. Mayank, for inviting me for this panel discussion. I'm right now with Terry in their Sustainable Mobility Group, working on various low carbon options for mobility. And also we do life cycle analysis and circular economy, etc. From sustainability point of view, also conservation of any resource which is not renewable becomes very, very important. And from that point of view, I think we need to work towards reducing consumption of various resources what Earth has provided us, and also try to use less energy so that the emissions from use of different forms of it, from where we get the energy are also reduced so that we will be able to protect the environment. If we don't do this, then we will not be doing justice to our future generations. As it said, we have borrowed the environment from our next generation, and we are supposed to hand over this to them in good condition. So basics of sustainability also suggest that we need to use or avoid using or use less of what is impacting the environment. So if it's not possible to reduce or not use something, India being a developing country. So we need to find alternates which have less impact on the environment. So we need to find newer technologies to replace what is not good for the environment or in terms of quantum of usage of various resources. So from that point of view, the weight reduction is a very important parameter. And also, as you mentioned, the auto industry always tries to improve the efficiency of its vehicles, and weight of the vehicle, gross weight of the vehicle plays a very important role in how the vehicle performs. Uh, Also, with reference to the various technological changes what are happening in auto industry, with the adoption of electric vehicles, and also talking about strong hybrids, etc., for reducing the GHG emissions. The more trust is required to actually optimize the overall weight of the vehicle, because the use of battery itself adds a lot of weight to the vehicle. So it is very important to optimize all the parameters to get the best out of the vehicle, what is being configured. And added to this, from Indian customer point of view, we also have to keep what is the cost of the whole configuration, what is being worked at. So because Indian customers are very, very price sensitive, and we have to make vehicles configure various systems to meet their expectations of performance and also price positioning.
Right. And I'll take that to Dr. Subramanian. Dr. Subramanian, like Rao-san just mentioned, it's a very broad perspective, and you have to look at it from a sustainability point of view. So your thoughts on it, especially coming from a CV manufacturer's perspective, is it only just efficiency improvement, or is it also an element of safety that you bring when you talk about lightweighting?
To us, yes, there is an element of safety, but I think efficiency takes center stage in terms of lightweighting, because it's a huge knob in terms of efficiency. It affects so many different efficiency parameters across the vehicle that I think it's imperative at this point. So it comes, I like to quote basic physics here, because this is something that is the governing principle for all automobiles, which is Newton's law, which says F equals ma, force equals mass times acceleration. And the m part is directly the lightweighting part, right? So there's only two things which talk about the effort required to move an automobile. The effort is the force. And out of the two, one of them, and with equal share, is the mass, is the weight of the automobile. And more effort you require to move it, the more the fuel consumption, right? So that directly speaks to the efficiency, to therefore to the running cost, and ultimately to sustainability, as Mr. Rao said. That's my very quick 2 cents on the topic.
Sure. Now I'll come back to you, to get specific perspectives about how you're attempting lightweighting in commercial vehicles. And before that, I'll take quick comments from, John, your thoughts on it. Why do you think it is important? And, what's the roadmap that the industry is following when we talk about, reducing the weight in the products?
Yeah, sure. So lightweighting has sort of raised its importance, I'd say, over the last 20 to 25 years. And with the oncoming of electric vehicles, it takes on a new level. The sort of the techniques of getting to lightweighting, there are various routes. Obviously, the vehicle design, the use of lightweight materials, which is in steel in particular, which has accelerated over the last 10 years. The steel solutions that are globally available now have really accelerated. As far as the sort of the key challenges for lightweighting for me, there's a number of issues. One is speed to market. your ability to optimize the vehicle during the design. The other thing, the big one for me is crash. And as cars get heavier, you need to put, as you were saying earlier, it's basic physics. You need more metal in the front end in the crush areas to be able to take that loading. So there are clever techniques around that, and we can talk about that a bit later on, I think.
Glenn, your quick comments on the broad topic.
Yeah, Mayank, I think it's very similar to the panel's discussion points so far. As we are a global leader of lightweighting structures to all our clients, we've seen a rapid adoption in India. Started just before COVID, been very much accelerated post-COVID. With the infrastructure of obviously the Make in India export to the world policy of the government. You know, the CAFE norms changed significantly post-COVID. We've now gone into global NCAP. And from that perspective, we see a dynamic shift towards lightweighting. That comes with challenges. We're still very much a maturing market in India. We don't localize enough content today as what we would like. It's bringing challenges to all of us, even our clients. But obviously, the adoption of lightweighting is becoming more and more prevalent as our growth expectations for India automotive sector will take us into the 2030s at, you know, certainly at number 3 position. You never know, we could push even higher. So there's a challenge ahead, but we're very much ready for that challenge and been ready for some time here in India. But there's a lot more we need to do in a fast maturing market, to be fair.
Right. Rahul-san, your thoughts on it? I mean, you know, as a glass supplier, you know, glass is also one of the fundamental elements alongside the sheet metal when you look at a vehicular product. So you being a key component of the entire sum of the parts. So what's your thought on this particular exercise?
Yeah, very right, Mr. Mayank. Glass occupies a substantial space when it comes to the vehicular design. More than 30% of the surface area is being usually taken up by the glass. And when it comes to the weight part of the glass, it adds close to 50 kilogram if we talk about the conventional vehicle. But now, since the usage of glass is increasing in the vehicle, as far as the domestic scenario is concerned, the solar sunroofs are being adding into the one of the significant area in the vehicle. So the total weight of the glass is coming out to be 70 kg, and it plays a significant role. And then AIS, along with its JV partner AGC, AGC stands for a Glass company, offer a host of opportunities to lightweight the vehicle without affecting the strength of the glass, which is a significant part, and also a regulatory component offering safety to its passengers. So we'll be talking more on these subjects.
Sure, absolutely. And I'll first want to start with Dr. Subramaniam. You know, I want to focus on the commercial vehicle segment first. So, you know, since today's topic is more from an engineering perspective, you know, the design, material, and the processes. So if you could quickly explain to us, you know, what are some of the key measures or some of the key ideas that you would have identified or you would have already implemented in reducing weight in a commercial vehicle, maybe a truck or a bus, an LCV or a HCV?
Yeah, that's a great question. And just as a very quick introduction, Ashok Leyland is a large commercial vehicle manufacturer. So we make buses and we make trucks of various sizes, from very small to fairly large trucks. And of course, the legacy was diesel. And we now have trucks on the road which run on LNG, run on hydrogen. We make our own hydrogen IC engines on fuel cells and also all electric batteries. All of these are live products, right, that we have put out on the roads. So like I think John mentioned, lightweighting takes on a new level of significance as you move to these new fuel systems, because everything else is all of a sudden more efficient, right? I mean, when you had an IC engine vehicle, you had the engine, which was the elephant in the room, and that was 38%, give or take at best. And that's not even an average, that's a peak. So, I mean, you lost 62% right away at the engine. So every other loss mechanism started to look pretty small. So um, when everything else is becoming more efficient, then lightweighting is taking on much bigger significance. We are looking at a lot of options. Some of them simple, obvious ones. Some of them big bets. We are looking at steels themselves to start with. I think that's a very obvious extension because automobiles like to be made of steel, I think. And so looking at better steels to do lightweighting is one of the big programs that's running in-house. We're looking at aluminum to select areas. But we have a very strong mantra that we want to do lightweighting at equal or lower cost. Right?
Right.
There is a business case for doing lightweighting at a slightly higher cost if the payback period in terms of the total cost of ownership works out to a very fairly short time. Because in the Indian commercial vehicle industry, the upfront cost also matters. It's not just the total cost of ownership. So upfront cost has to be kept in mind. So therefore, aluminum may not be that attractive because it comes at a higher initial cost. We are looking at some innovative ways to use composites. I mean, if you go all the way to carbon fiber, then the cost goes up significantly. And again, I'm talking commercial vehicles, so cost is a very, very big knob. And if so, that therefore we are working on some very interesting composites, which is not all the way to carbon fiber. So you can call them hybrid composites if you like. But then we're exploring all this, right? We are exploring combinations of materials. So it need not be one size fits all kind of a solution. It could be various different things. But I think one thing we have kept in mind is as we go to these new materials, it cannot be a one-to-one replacement with steel. We'll have to seriously rethink how the automobile itself is designed, because if we think in a very linear fashion and say, I'm just going to replace steel with some other material and I'm going to reduce the thickness, then lightweighting isn't really quite working in terms of cost and the benefit in terms of efficiency. So a lot of the effort is actually focused on how do we rethink and redesign how the vehicle itself is built. And I think EV is giving us an opportunity to do that, because EV is not by definition simple extension of the diesel platform. It is something, I mean, it can be an extension of the diesel platform. You can throw out the engine and put a motor there in the same place. But I think EV is giving us that opportunity to say that, I mean, you can think of a completely different looking vehicle structurally, in terms of transmissions, in terms of everything. Right. So lightweighting is not just the structure. So that's the final point I want to make. It's also about rethinking whether some of the legacy parts are actually necessary. So you may be able to eliminate certain things. For example, with a diesel engine, the engine was in front and the wheel was in the back. The driven wheel was in the back. So you had to have what we call a transmission, which transmits power from the front to the back, which is a propeller shaft, a universal joint, a gearbox, a clutch, a differential, a whole set of baggage, right? So with EV, it's giving us the opportunity to ask these questions. Does the engine really need to be in the front? And it's not an engine. So you can take the motor, take it all the way to the rear axle and put it on the axle, which means you eliminate components. It's not just about replacing one material. It's about innovatively eliminating what you actually don't need.
And I want to press you a bit further. You mentioned that when you consider all of these different innovative ideas, you're looking at a payback time. So what sort of is the ideal payback time when you consider the the cyclical nature of the Indian commercial vehicle industry?
Very, very tough question. I think it's a very case by case kind of answer. It depends on what kind of a vehicle it is, what kind of an application we're selling into. So, which is why if there is no cost increase or if there's a cost decrease, then of course the payback time is zero, and it's an easy sell. Otherwise, we'll have to deal with it literally on a case by case basis.
Okay.
And approach a particular customer, ask that customer if for that particular kind of weight saving and for that application, whether the payback makes sense.
Okay, right. And you mentioned about design, so I'll go to John. John, I mean, you heard Dr. Subramanian talking about design, completely redesigning the entire thing, and maybe in case of EVs, you're looking at ground-up designs of the entire platforms. So your thoughts on it? How are we looking at the structural engineering changing going forward, and you inherently incorporating lightweighting properties or attributes within the structure itself, so that you're able to reduce the overall weight of the vehicle or the BIW.
Yeah, there were some really good points made there. The philosophy of rethinking the EV, it does give really big opportunities, and a good way of looking at that is benchmarking. If you look at where the competition's going, first generation EVs were very much almost a substitute. Just before I go too much, obviously working with Tata Technologies, we're an ESP, so we deal with a whole range of different customers. We could be working on a very premium, low volume customer on one hand, and on the other hand, we could be working on a low cost, high volume. And to be honest, that's where the challenge is. I think, like commercial vehicles, the challenge is in the cost, is in the low cost vehicles to get that lightweighting into those. So the big opportunities with EVs is you can look at proportions to get a good crash. The biggest significant challenge for me when I'm working on a new vehicle, and we've developed our own platforms in a way that we sell those platforms to startup companies because the platform is so key. If you have a platform that meets a lot of your attributes and your requirements, that's a huge start in the process of developing vehicles. That platform obviously needs to be developed. If it's a global platform, it needs to meet some really severe crash standards. Yeah. One of the trends that EVs are doing is putting the motor in the rear of the vehicle. I think you went back to something like 1938 when the Volkswagen Beetle, the original one, had an engine in the back and it had all sorts of problems because of handling and so on. Now with sort of modern technology, putting a motor and a direct rear-wheel drive in the back of a vehicle opens up huge opportunities at the front of the vehicle because suddenly you've got a lot of crush space. So when there was a big engine in there, we used to call it a locked out area. So, excuse me. So by freeing up crush space, you're able to manage the deceleration of the vehicle and therefore avoid occupant injuries, and it makes life a lot easier. That combined with, like I was explaining earlier, there's been a really big progress in materials as Glyn come back with the type of products they're producing. The use of high-strength steels has made a big change, particularly in the premium market. If you look back, say, 7 years ago, and even 15, 20 years ago, people like Audi and Jaguar Land Rover, their saloons were all virtually 100% aluminium. If you look at the latest vehicles, they're multi-material. So most they've got about 30% aluminium. That's because the new steels are so efficient that to get the aluminium to work in the same way, you'd end up with very thick, inefficient panels. Obviously, that brings challenges as far as joining is concerned, galvanic corrosion, for example, between the steels. You also have to worry about contamination within the assembly areas as well, especially when you're looking at closed loop recycling. But that's certainly, like I say, that's a trend for premium cars. For global cars, we're seeing a real big adoption of press hardened steels. Volkswagen was most probably one of the leaders in that with the original MQB platforms, and then they moved on to their MEB platforms as well. So, yeah.
Sure. And I'll take that to Mr. Rao. Mr. Rao, like what John just mentioned, it's a bit of a challenge when you talk about high volume, mass market, and low cost products. So, from your experience, you've sort of worked in that in the meat of that space, I mean, Maruti Suzuki is the mainstream, the mass vehicle category, from the right from the Alto to the the Wagon Swift. That's a very cost sensitive zone of the Indian market. So from your experience, is it very challenging to engineer lightweighting into those products? And from your experience, some anecdotes that you could share with us, what sort of different techniques that you've adopted in the past to achieve lightweighting in this category of products?
Yeah, it's a very interesting question you asked. Actually, in case of Suzuki Motor Corporation, that's what we have inherited from them, Maruti. Whenever we develop or work on a new product, new model, one of the first things what is targeted is what should be the weight of the vehicle. And then that gets distributed to various systems, and each system designer is given the target to develop the system within that weight target. Of course, the cost target also is assigned for each group. And some of the basic strategies used by Suzuki, which we also adopted, is the effort to reduce number of parts every time you are coming out with a new product, and also try to eliminate fixing of various parts, especially sheet metal parts, by using nuts or rivets or screws and bolts. Mostly it's spot welding which is done, so that also helps in reducing the weight. And also, we had used Teller welded blanks where some local portion of the total panel required strengthening and not the whole panel. So there, the high strength material is welded with the low strength material, and that is used for making the panel. So high strength material comes at the place where the higher strength is required. Then, of course, use of high strength steel has become very common practice now with the compliance to crash and other things getting mandated. But as you mentioned in the initial remarks, still we have to import high tensile steel from Japan or other places, because in India our steel plants are still not making high strength steel. And also the cold rolled sheets what are required for the automotive application to the quality requirements of passenger cars. So, and also in Suzuki and in Maruti, we used to have a lot of initiatives where challenges are given to the designers to reduce the cost of even running models, different systems, how to reduce the weight without sacrificing the performance of the system. So I think once we have that focus for weight reduction, I think when the engineer works on the design or configuration of various systems, he automatically a lot of importance is given to how he is configuring various sections, etc., which would help in reducing the overall weight. One very good example, which I keep quoting everywhere, which I think Raman also mentioned yesterday, is the 3 generations of Swift what have been already, seen in the market, and 4th generation is what is there in the market now. I'm starting with the first Swift, which was launched in 2006, which was bigger in size and heavier. Next model was more compact and of less weight, and complying with more safety standards requirements. And the 3rd generation, which just was phased out last month, was the most, compact with more passenger cabin space and also lighter compared to the previous generation. And it complies with all the offset crash and other safety norms which have been implemented subsequently. So it all, other point which Ashok Leyland, Mr. Subramanian also mentioned, this is much easier to do when you are actually conceiving the product than doing it later for specific weight reduction. Of course, that's also possible. Then it becomes a lot, the number of constraints which come into play are many more if you are working on an existing model. Whereas if you are doing all these things when you are actually conceiving the model, it's much easier, simpler.
Right.
But what is important is the focus has to be there.
Right. I want to take a quick comment from you, John. Mr. Rao just mentioned that, right from the conceptualization stage itself, you have to factor in lightweighting. So is that what the industry approach is right now?
Yeah, without doubt. I mentioned that the crash is one of the biggest challenges. Obviously, if we go back to ICE engines, then the fuel emissions, the weight is absolutely strategic. So planning lightweighting from day one is absolutely fundamental. There are techniques, as you know, you can look at optimization techniques within CAE, topology optimization, later in the program, but that, as I sort of touched on earlier, that's now being challenged. The time to do that is being challenged. Historically, if you look at someone like Mercedes-Benz, they took 7 years to develop a new platform through to the first vehicle on the road. Chinese OEMs now are looking at around about 26 months. So those extra loops of optimization are not there. So you have to get it right first of all. So the planning of the vehicle and taking every opportunity you can. Part reduction, I think someone touched on that earlier, is one of those many ways of reducing weight, because you have less joints, you have less welding, or you have less bolts, or whatever your joining method is. Obviously, there's a lot of noise in the system now with Tesla looking at mega castings. There's a lot of advantages around those. It's almost... I've seen in the industry over the last, I've been in it 40 odd years, and I've seen the sort of steel and the aluminium battle of the two trying to win the day. And this is aluminium's latest attempt to steal some of the volume from steel, I think. I'll be honest, I think there's a lot of advantages, but I'd like to see where the future goes with these castings. I think there is a call for a real independent analysis of traditional versus mega castings.
Right.
But it's nice to see. We've been building cars for very similar techniques for over 100 years, and people are challenging it now. But what has changed fundamentally is as you said earlier, it's absolutely the initial planning. The platform that I said about earlier, and the fact that we've developed our own platform, gave us lots of learning, and we've developed that platform with a couple of OEMs and got a lot of learning from that, which we find that there are techniques that you can adopt right early on. As I mentioned, vehicle dimensions, vehicle packaging. If you get them right earlier on, that can save tens of kilograms of weight. When you get into the validation stages, when you get into crash testing, strength testing, you may end up putting a lot of weight into the vehicle because it doesn't meet the targets. If you get those targets right at the start, that's super important.
Right. And you also do it in a very cost-effective execution.
Exactly. Yeah. You're absolutely right. I mean, the more material you use, obviously, the more expensive it is.
Right.
So the lighter you can make it. Right. You use more expensive types of materials to get it lighter, but if you can use that in an effective, an intelligent manner.
Right.
Hello.
Conversation, but I'll come to you. Want your expertise, your expert comments on. We've been discussing about these advanced materials as a means to reduce weight in vehicles, and we're already seeing a lot of OEMs deploying them. But like how John was mentioning that they're more prominent right now in the upper segment of cars. The premium segment. And if you could, from your perspective, make us understand about, the challenges that we are seeing here when you talk about the ultra high strength steel, the advanced steels, and just from your perspective as G-Stamp, what is the technology roadmap that the industry is adopting when it comes to the stamping portion, which is the fundamental of a BIW?
I think it's quite a fascinating debate today, because obviously John's touched on some relevant points, and obviously Mr. Rowe's touched on some very, very relevant points when it comes to cost and optimization of the body weight as well. I beg to differ a little bit, Mayank, on your comment about how we can make ultra high strength steel more competitive. John's absolutely correct. What we've seen here from a Gestamp point of view in India over the last 2 years is our clients are trusting us as a supplier more and more to give them the value optimization as early as possible. And by giving the value optimization right from day one, we're able to give them a optimal solution as quickly as possible. And John's right, the likes of our historical OEMs, big clients, have taken a long time to bring to market mature platforms. In India, we've tried to adopt a different approach in the last 2 years. Certainly, our clients have changed and realised the need to bring to market the products in a faster time cycle is going to be beneficial to them in the long term. We've got a lot of advanced tools and technologies and CAE data around us, and we've also got what we call our G-Lab models, which takes the whole portfolio of platforms, and we plug and play what we see as the dynamic loads, so we know from model to model, from client to client, where the industry's going and where the content's moving to. If I take, for example, back in 2016 in India, our average hot stamping content was very, very small. And the content per vehicle was only mainly prevalent in our multinational global clients. Indian clients were not very receptive to that technology at that time. If we look at today's scenario, average content of hot stamping materials for lightweighting solutions today is probably around about, in percentage terms, 40% more than what it was in 2016. If I look at the future, the multi-material concept will continue to grow. There is a debate. John's absolutely correct. The Giga casting solution is one solution to the lightweighting conundrum that we're all facing. We have in Gestamp the Giga stamping concept, where we can do similar structures to the casting, but not in so much complexity. But it still allows us to optimize the structure of the vehicle to meet the client's requirements. Premium cars will obviously be able to absorb that cost better than low cost. But at low cost today, we see a fundamental shift. Our mainstream players in India, with all due respect, with not including Maruti at the moment, but the rest of the market is switching to more adoption of hot stamping and ultra high strength steels. But there's a trade-off. Obviously, the market is extremely cost sensitive. But at the same time, as we've just mentioned, we play a fundamental role now right at the early stages. I mean, we've been working here for a long period of time, since 2008. But again, in the last 4 years, we've seen a fundamental shift in India, fundamental shift. And without naming clients, one in particular springs to mind has been extremely advanced now with the adoption and the design of multi-materials for their future platforms. And that's good to see, because it's not just about hot stamping. It's not just about Giga castings. It's about the whole cyclic economy of how we can reuse and benefit the environment going forward as well. And hot stamping material is one avenue. Aluminium is one avenue for us to pursue. But we've got the cold stamping 980, 1180 megapascal material. But when you look at the environmental impact at the moment, it's a challenge, because most of those materials have to be imported into India. I think Mr. Rowe made a point that we're not very mature yet with the steel mills in India. But I think that's going to come over the next 2 to 3 years. I know there's a lot of infrastructure plans talking to our steel mills in India. They're understanding the shift in the market, and we're helping them as well to forecast where we see as a supplier, where we see our forecasting going forward, and where we think our clients are going to be focused in the future. It is a challenge, but it's one we're excited about from a Gestamp point of view. We're very optimistic about the future, and it all depends on the volume curve as well. The more we adapt certain technologies, the costs will ultimately come down. We've seen it in the EV. We've seen it in, for example, in China. The cost of an EV now is it's in a battlefield in China, to be perfectly honest. It seems every day there's a reduction in price from somebody. But still the new players are able to compete. I was reading this morning on Bloomberg, Xiaomi, massive increase in sales. So even though the market's challenging, the economies of scale are starting to play into the content of the vehicle price, and we are rapidly maturing in India, and you can see that in the success of the numbers. You can see that in the market predictions, both on passenger vehicle and obviously on commercial vehicles. It's a positive trend, and we are very confident going forward that with our involvement as early as possible, we can further optimize. And that doesn't mean just PHD, press hardening. That could be aluminium. It could be multi materials. It's not just about one material grade now, because obviously it will change the dynamics. BEVs are key for crash performance. There's a safety element in BEVs that wasn't prevalent to us when we were designing for our clients the ICE body structures and helping them on ICE. But obviously now it's different. But it doesn't necessarily mean that we have to use the most expensive material. So it's a challenge, but we're excited about how the industry's starting to take up the advantages that they see from how we intervene and help them at an early stage.
Right. So with this localization of these advanced steels, Glenn, so would you want to give us a sort of an estimate about the penetration levels we could see of these materials in the mainstream mass market cars, which are the mainstay in the Indian market?
I think if we look at it today, I think even on the cold stamping materials today, I think everybody's now focusing more around 780, 980, 1180 megapascal material. So that penetration's already starting to come. I think we've pretty much been able to successfully localize 780 material. 980 and 1180 are very much under discussion at the moment, but still, I would say 12, 18 months away, some real signs at India mill level that they got stability. Hot stamping materials are already here in certain mills in an uncoated form, which again, for India market is more than suitable for the requirements in India. We tend to see more coated content for export models. That's not with us at the moment in India, to be fair. But again, we're optimistic in the next 2 years that certain mills are bringing to market commercially viable PHD coating grades. That's going to help us even more, because obviously we care about our ESG targets in Gestamp very strongly. We're pushing our mills to support their targets and our targets, which ultimately goes to the client's targets. And we are well on the way to being carbon neutral by 2030, which is our goal for Gestamp. So so in India it's even more prevalent because we're coming from a further way back from our other plants globally, but we're catching up very, very quickly.
Right. I'll come to you, Rahul-san. From your perspective, some of the innovations that we could expect going forward in the area of automotive glasses, when it comes to reducing the weight of the glass itself, which in itself is quite a heavy component.
Right. Since ages, we see that the manufacturing of glass is fairly dependent on the soda lime glass. So the strength which is being imparted in all the safety glasses have two different type of process technologies. One is the laminated glass, which uses a annealed glass, and then your door glass and your back door glass are tempered. And when it comes to providing a lightweighting opportunity in a vehicle through glass, which is a fairly high weight component, so we are dependent upon reducing the thickness there are certain techniques where the strength of the monolithic glass can also be increased, but when it comes to providing the regulatory measures which are required for a human safety in terms of when the vehicle goes for a crash. So those are not prevalent right now in the automotive industry. So we can provide about 11 to 14% of weight reduction through the lightweighting techniques in glass. The thickness of the glass is reducing from a conventional 3.2 of tempered light to 2.8, and now we see the trend is moving towards also adopting 2.5 and 2.6 mm of glass, which will give 11% of 16% of weight reduction. And in laminated, which is a combination of 2 plus 2 mm of thickness, the trends are being seen where the outer layer of the vehicle glass, which is we call it as phase 1, is still the 2.1 to resist the impact of the stone which are flying from the roads, and the inside of the glass we are able to reduce the thickness to 1.8 to 1.6. There are certain developments going on where the inner layer of the glass is also being produced at 1 mm of thickness. So the total weight reduction is close to 16% is possible when it comes to providing new age glasses in automotive without compromising with the strength.
Right. And also, Rahul-san, with the move towards EVs, when you completely eliminate the IC engine and the noise from it, so I think the role of glass becomes even more important in controlling the overall NVH of the vehicle. So how is
Right.
that going to be a bit of a challenge for you? You're also reducing the thickness of the glass and you also have to meet more stringent NVH requirements. So if you could explain a bit on that.
Yeah, so both ways. So as we are reducing the thickness of the glass, of course, the NVH is counterproductive here. So the technologies which are coming in to replace this menace is either we can go by adding laminated glass, a thinner laminate on our door lights, and also we can assume the same for replacing tempered sunroof to laminated sunroof. So we can compromise this noise and noise by adding the acoustic interlayers in the laminates, and there is a possibility to reduce close to 40% of sound transmission loss into the vehicle. EVs are fairly silent vehicle, so what is becoming more prominent inside the cabin is the noises which are coming from the streets. So street noises are in the range of 2,500 decibels to human ear. Um, uh, so, so the addition of the acoustic interlayers in the laminate provide dampening to that kind of sound frequencies, which will be compensated by using these um, acoustic interlayers in the glass. That is one part of providing the value addition. The other part is that the moment we are going thinner in the glass, we are increasing the light transmission into the vehicle and thus adding heat load into the cabin.
Correct.
So there are certain technologies where the different things are prominent in the vehicle, but with adding interlayers of solar acoustic, the solar properties can also be tweaked, and 14 to 15% of radiations can further be reduced, even though when you are reducing the thickness of the glass.
Okay.
by these technologies.
Right.
So these are coating technologies and also adding interlayers into the vehicle.
Right. Right. Now, before I go to Dr. Subramaniam, Ramsan, I just want to press you a bit further. What about the cost increase in this entire exercise? I mean, you're talking about a lot of technology being, infused in the glass itself, which to a layman might just look a very, traditional non-tech part. So how do you plan to manage the cost delta when you're looking at so much of technology infusion in the glass?
So when it comes to, again, it will be a case of how we are addressing the mass market volume needs
Mhm.
in adopting the lightweighting value proposition in glass. Since as we are reducing the thickness of the glass, obviously we are using less glass, which will be comparatively cheaper than the higher thickness of the glass. But then we are adding a lot of energy into the processing of glass to compensate the loss which may happen due to reducing the thickness in order to
Right.
providing the same values of toughness in the glass. So 3 to 4% is what we see the difference is coming in the cost, which is fairly being compensated by improving the operational efficiencies. So I would say it's not going to add cost.
Okay. Okay. Sure. Dr. Subramaniam, I want to ask you a very related question, around glasses and what we just discussed with Rahul sir. In the commercial vehicle segment, we are likely to expect the cabin norms coming in, and there's a prerequisite of ACs, AC cabins pre-fitted from the factory. So when you look at those regulatory requirements, and on the other side, you look at lightweighting. So how do you plan to, solve those challenges?
You're waiting for the glass industry to help us out, but we are working with actually quite a few efforts happening with the glass industry as such. See, the holy grail for us is to have a glass where we can get the light and not the heat. Right?
Right.
I think there are technologies along those lines. How many
Right.
of them are commercially viable, I don't know. There's also what we call the A pillar and the B pillar and all, which
Right.
is another. I mean, ideally, everything should be glass, right? And if glass is strong enough and light enough, I think that's the answer. But then you also mentioned noise, and there is another source of noise at least in commercial vehicles in the electric, which is the air compressor, because a lot of the medium to heavy vehicles still need air brakes.
Right.
And I don't see line of sight in India, at least, to getting out of air brakes.
Okay.
At least in the near future. So there are other problems in terms of noise. So it's not just the glass shielding the noise.
Okay.
So the compressors have to get much better and much lower in terms of noise. Right.
Right.
Was that your question, or?
Yeah, no, that answers a part of my question, but I would like to ask you a bit more on the air compressor itself. So within that component, are you looking at more of, fine-tuning to lower the weight of that particular part itself?
Correct. So compressors are moving to e-compressors,
Right.
which can hopefully be controlled in a much finer way versus the regular compressor that's driven from an engine. So these are all live projects that happen. Yeah.
Right. Okay. And Glenn, coming back to you, some of the manufacturing processes, if you can shed light on, and you've talked on hot stamping and cold rolled sheets, and even Rao-san just mentioned a bit on, the tailor welded blanks. So, or maybe if we can just, discuss a bit more on the Giga stamping or the mega stampings. I mean, yesterday also in our keynote, we touched upon that.
It's a fair question. We saw. Can you hear me?
Yes.
Yeah. It's a good question. We introduced the Giga stamping technology in India at the start of this year, predominantly to obviously give our clients more value add. But at the same time, it allows us to become more creative with the solutions we can provide by doing that process. Coupled with the latest technologies we have in Gestamp on our energy efficiency, we took the strategic decision that it was right for India to start to introduce that to our clients here. It's as I say, it's allowing us to have more design freedom with the clients, so that the clients get a little bit more design freedom. It was very interesting that Dr. Subramani mentioned about the A pillar, B pillar needing to be glass. You know, I've heard that a lot. I am working with a couple of commercial vehicle guys at the moment, and they're equally conscious about where they can optimize. But as our technology continues to mature and the materials become more mature, we can specifically target now in India where the crash relevant areas are. We can tailor our process to meet the client's needs only in that area. So where we need to add strength, we will only add strength in that area. Where we don't need to add strength, obviously we can optimize the weight even further. Right. TWB is one option. We've got a patented solution in Gestamp called overlap patch, which again is a different context to the TWB. There's also TRB, Tailor Roll Blanks, which is very, very important in the industry as well, which again gives us another optimization stream to try and take weight out of the vehicle. But our processes today are already very, very advanced. I think it was interesting that Raoul was mentioning about weight and cost prediction savings. It's very easy to say you can save weight and you can save cost, but in reality, you know, one has to trade off against the other. We see on vehicle weight now, on the projects that we've been working on in the past several years, average transition between what would be a normal cold stamping material up to 780, transitioning towards 980, 1180 and PhD, we see an optimization of around 15 to 20% in weight saving terms. Now, obviously, some of that's offset by cost, but generally, even now, the number of parts in the body shell is significantly reduced. Right. So again, the clients are getting the benefit of that as well. So I wouldn't say we're net zero in terms of cost. We could end up eventually being net zero once the raw material element is more of a localized content. We could foresee in the future being net zero, but today there is still that concern in the market, especially in India, where we import material. Our clients are very cautious when it comes to the content of import material. And obviously the government norms are changing a lot. I think we've all seen BIS regulations change. Specifically this year, we've seen a lot of changes in BIS. Anti-dumping is becoming more prevalent in India. And that's only going to be a good thing in the long term. It helps us become more mature as a market, and obviously the benefit will ultimately get passed to the consumers. So that's the long term. That's the long term view. But we're here. We're ready. We've got the Giga. We can save at least 15% today on the Giga stamping technology versus the previous PhD technology that we also have here in India. So combination of parts, bigger parts, specifically giving the customer and the clients what they need in the areas where they need it is also a big part to play. And I'm sure John and Mr. Rowe will also like to add, you know, we crash sensitivity. Design teams don't want to put too much weight into the vehicle. They're always challenging the suppliers to optimize, and obviously it's always a difficult trade-off. But what we see now here is our technology is very much mature globally. The next journey is already here for us in India, and our clients are very receptive to what we can do. And you know, the interest is picking up very, very quickly.
Okay, so when do we see this time commissioning its Giga castings in India, Glenn?
Our first Giga stamping line is in. It's here. It's in Pune. It's in production. It's in production for one of our local OEMs, predominantly. So it's already up and running. I'm sure in the future you'll see a lot more publications coming from us on what we're doing in terms of the next evolution of PhD. But again, we're not just here for PhD. You know, we fully understand the clients' requirements now, and we work very, very, very closely with our clients, to be fair, to where we were probably 4 years ago. There's a lot more early supplier involvement because it helps us and it helps the clients ultimately. I mean, John from a technology point of view will say he's got platforms that he can sell to his clients. You know, we would work and optimize those solutions as well, and then it becomes very much a simple plug and play, and that's what our clients are finding. Once they understand the design limits and limitations of PhD, it becomes much easier for them to then have a little bit more degrees of freedom when it comes to design.
Right. And coming to you, John, you know, I mean, yesterday we were having this discussion, and you know, we were just trying to understand the adoption of Giga castings in India. And you know, there was a concern from a Tata Motors representative, Mr. Anand Kulkarni, that you know, in India, you also need to consider the fact that you know your serviceability needs to be one of the key requirements because the products are kept in the ownership cycle for a very long time. So you have to have multiple child parts, even in the structural part of the vehicle. So from that perspective, how do you see Giga castings unfolding in the mass market segment in India?
Yeah, it's a really good question. Obviously, when you design a car, there's many aspects to take in account. The facilities that are available within for us, you know, it's the facilities within the OEM. Is it a greenfield site, which would then encourage the option to use more radical type solutions with that customer? But if it's a brownfield site and they have a large carryover target of manufacturing, then it restricts what you can do. But service, for sure, there's sort of two big challenges in my view. There's global supply and availability of materials, and then, as you say, very much serviceability. And aluminium is, you know, very difficult to service. In the early days of the Audi A8s and the Jaguar XJs, they had to go to specific service centres to be repaired, and so it's a challenge. It's going to be a real difficult challenge if mega castings become adopted on India products. That the whole sort of life cycle support process needs to adopt with it. Really, interestingly, we touched on the sort of adoption of high strength steels, ultra high strength steels, PHS, and advanced high strength steels. We've seen, I've sort of observed over the last 20 years, a lot of trends. We've seen, to be honest, Europe sort of led the charge with the higher strength steels, the greater megapascals, and then other areas have followed very quickly. Japan was a little bit slow in adopting ultra high strength steels, PHS, or boron, however you want to word it. And it sounds like maybe in your market, some of the indigenous companies may adopt these high strength steels quicker than maybe some of the non-indigenous companies as well. And certainly in China, particularly, which is obviously a huge market, they've really been fast followers on advanced high strength steels and ultra high strength steels. I think the last time I looked on my trend in sort of globally competitive cars, vary sort of the ultra high strength steels, PHS, press hardened steels, around about between 5% and 20% of the body, of all the body panels. The sort of the leading OEMs using 20, even over 20%, some of them. Advanced high strength steels, they're around about 15 to 25% of the body. So a lot of the body now is being made up of high strength steels, on the basis that you've got so many different load cases. You've got the safety load cases, you've got bending and torsion, which needs to be good. And with EV comes extra load cases. You've got to protect your batteries, side impacts, The NCAP and IIHS side impact tests are very severe. So a lot of structure needs to go in to support them. The rear end also, I mentioned earlier about putting motors into the rear of the car to make the front end crashes. When we go to the States, the rear end crash is also extremely severe as well. So and that's one of the main reasons why globally competitive cars have adopted these type of materials. One is obviously weight, but the other part is the challenge of the load cases. And obviously, if you didn't have these lightweight materials, you'd end up with an incredibly heavy car. The other point to make is electric vehicles that we touched on earlier. When you've got a lot of money, there's a real cost challenge on electric vehicles, as you've mentioned. There's technology is attracting a lot of money, whereas on ICE engines, the body and the chassis were quite prioritized as far as performance and ride and handling. On EVs, there's a lot more sway towards connectivity, regenerative products, and battery sizes. And I think on an EV, if you save 100 kilograms, you'll only get approximately 7 kilometers range increase, which that's very small for this amount of weight and the cost of the weight. So the focus is not to spend too much money on the body, but actually put it into regenerative technology, put it into bigger batteries. So the cost challenge versus the weight becomes a greater challenge. And that's where we need people like Gestamp and so on to keep bringing out these new technologies, optimizing technologies so we can work in a partnership with them.
Right. Before I go to Dr. Subramaniam to get his perspective on Giga castings in series, Rawson, I want your perspective on this. I mean, on Giga castings and also on some other materials, we've seen in your case, in Suzuki's case, like we've discussed aluminium. So in the small cars, we've seen aluminium being used primarily in the powertrain. I mean, all the Suzuki engines today are all aluminium. So going forward, do you see the aluminium use case becoming, it getting diversified a bit more into the other parts of the vehicle as well? You're on mute.
Yeah, what you said is right. In case of Suzuki, all major parts of engine have been converted into aluminum castings. And there was a project where they were working on even modifying the knuckle suspension parts also to aluminum.
Right.
Actually, in Suzuki, there is a continuous effort to find alternate materials which would help either in improving the performance or reducing the weight. So it's a continuous ongoing project, and definitely there is a lot of focus on finding ways and means of replacing what's being used to a lighter alternative. Actually, it's difficult for me now to say specific cases what Maruti is doing. But general direction is this. So as far as engine is concerned, all engine cylinder blocks are also aluminum castings. And of course, transmission and cylinder head, everything was already aluminum casting from day one. And a lot of transmission inner parts also, they are actually modified to aluminum pressure castings.
Right. Could you shed some light on some of the composites, or even in case of joineries, we're looking at a lot of adhesives being used now in the industry. So what is the trend there when you look at some of these alternative materials?
As far as the plastics are concerned, other than the interior parts, there were some projects to actually do some outer panels, door outer panel route in plastic. But I don't think it has been actually productionized as of now.
Okay.
Mayank, if you allow me, I have a question for Rahul.
Please.
Whatever reduction thickness he has talked about, have we implemented them in India?
Yes, sir. These are now prevalent in most of the Maruti vehicles.
Okay.
Maruti is adopting most of the temper lights and lightweight segment of our glass proposition.
Okay. Thank you.
Not specify the thickness, but yes.
Thank you.
Sure. Dr. Subramaniam, I'll come to you and, first thoughts from you on, on the Giga castings that we've been discussing. So, in your case, when it comes to a big product like a commercial vehicle, do you also see a possibility of Giga castings being used there? And this is also a question from one of the attendants in the audience, I mean, he also wants to understand, like for which commercial vehicle parts could Giga castings be used in the future?
Yeah, I think we are just looking into it right now. It is definitely an area of interest for us. For sure, commercial vehicle industries would benefit from Giga castings. It also speaks to the point that I initially made in the sense that if we are going to more and more complex designs, just because we have to optimize the designs will naturally become more complex. And I think the Giga castings will also help us in that regard. Right, because there's nothing else out there in terms of manufacturing complex designs except for 3D printing, which is expensive for mass production.
Right.
So yeah, I mean, we should be looking more into it. That's my simple answer to this.
Okay, right. And when you talk about the electric commercial vehicle space, and you also have a separate entity altogether, Switch Mobility. So when you talk about those electric products, so like I was just discussing with Rao-san, the application of some of the composite materials. So do you see that becoming more prevalent when you consider electric commercial vehicles?
Yes, for sure. And just to clarify, Switch Mobility, our sister company or our subsidiary rather, it actually makes electric buses and electric light vehicles. Ashok Leyland makes electric trucks.
Right.
So we also do electric, and not just for electric, for some of the other powertrains like hydrogen.
Right.
I think composites for sure make sense. We are going piecemeal at the moment. We're trying to see just at which parts composite makes sense. But I think like going back to the discussion again, the born EV is where we really need to bring in composites, right? Because it's proving difficult to just do a one-to-one replacement of existing parts. I mean, there is an advantage to making an EV using an existing platform, because case in point in Ashok Leyland, we have a very modular platform. And the reason we were able to make trucks of all sizes using for EV is the fact that our platform is modular. We can reuse a large number of the same parts to make an electric. But that same idea also may work against us in the born EV concept. And born EV is where the composites seem to fit better. But as I also initially said, it's not just, when you say composites, I think it's a big word. There's a lot of different kinds of composites. So to me, any combination of materials is a composite.
Okay.
Right. I mean, if the percentage is very small, and if it's a metal, I would call it an alloy. But in any other definition, I would say any combination is a composite. So we are working on, based on that definition of a composite, trying to see where composites will fit into the commercial vehicle industry.
But in general, if we talk about some of the plastics heavy composites, like in case of passenger vehicles, we've seen the rear hatch, the fenders and all going towards plastics. So is that something we could expect in the e-commercial vehicle space as well?
I think so. I mean, we are already working on, for example, introducing plastics into some of the crash absorbing systems, because there's certain classes of materials are good at energy absorption. Again, one-to-one replacements. But I think the holy grail is to replace structural elements with the plastics or composites. That's the dream. That's what we want to do. And we are trying to see if we can.
Right.
That will seriously make a difference as far as commercial vehicles are concerned.
Right. John, would you want to comment on that? I mean, use of composites and particularly plastics in commercial vehicles. So would that also help towards crash enhancement, crash performance enhancement in these vehicles?
Yeah.
Apart from lightweighting?
Yeah, we've got a lot of experience working with composites. We did for a northern
to second that, because even we are looking at the use of structural adhesives to even replace welding in many cases, and it's not just a cost saving exercise; it's even reducing dependence on skilled welders, and it's cutting the amount of time required to weld and create a structure significantly. Yeah,
agree.
Yeah. And I think we've had a fair round of discussion over the last 1 hour or so. So I'll now switch to taking questions from our audience. And we have a question which is on Giga castings, and this is from Mr. Millen. Glenn, maybe you could take that, you know. So the question is, if we do adopt Giga castings, so will the cost go up or down? That's his very broad question.
It's a difficult one to answer. If I use the scenario of Tesla are obviously seeing the benefit because obviously they've got the volume, and they see the volume and the capex, the overall capex to bring the body shell to the trim line as being optimized with the Giga casting route. In India, I would say at the moment the volume's not there to justify Giga castings, but that's not to say in the future the volumes won't appear. And I think as the technology becomes more advanced, it's like the mobile phone. Originally, it was 7, 8, 9, 10 kilograms for the battery and the mobile phone. Now it's put in your pocket and you lose it most of the time because it's so light. The equipment today is very, very advanced and it's very, very expensive, but it will come down eventually for sure. And I know there's a lot of interest around the Giga castings. We've gone the Giga stamping route because obviously our investments are still very much there and adaptable. So we've done a lot of work in adapting our existing processes to do the Giga stampings in the same investments we've currently got today. So it'll be an interesting one. It's very similar to aluminium. You know, it's which way will it go in the future? It's all about the economies of scale. It's all about who's willing to invest and localize those materials in the region where it's growing. And I think India is a growing region, so I'm assuming that somebody will have already studied the fact that they need to bring more aluminium raw materials to the market in India locally and not rely on the imports. Once we get that, that's the next evolution, as it is with the ultra high strength and the PHS material. The more mills adapt quickly to the needs of the market, obviously, ultimately, it's going to bring the cost down. But if you're asking me, do I see that in the next 5 years in India? Today, I would say no. But then again, 2 years ago, we would have said BEVs were still very much in the immaturity, and now we're seeing a complete switch 2 years later. So the market's very dynamic at the moment. So I wouldn't say I won't see it by 2030, but the likelihood of seeing Giga castings in India at the moment, talking to our current clients' portfolio and their understanding of what they want to bring to market, I don't see visibility of Giga stampings at the moment in India.
Okay, well, I'll take the next question, which is from Mr. Mahesh Geepe. And I think Rahul-san, this is directed to you, even though it's not directly related to lightweighting. But the question is, what are the glass coating techniques which are being deployed to reduce UV radiations inside the vehicle?
See, there are two types of UV reduction which are possible in the construction of glass. When it comes to a laminated product, so by the use of the polymer interlayer inside the glass, so UV is almost 100% blocked. Then what options do we have for the tempered glass, the other glazing? So in AIS, through our JV partner AGC, we offer super UV cut glass to our OEMs. In Japan, there is an adoption of more than 70% of use of super UV cut glass in tempered glass, which uses a specific inorganic coating inside the glass that blocks almost, again, the more than 90% of UV. So you can then have a complete vehicle cabin almost 100% UV protected. Is that answers the question of what different technology we have, UV coating? Yeah, so both are available nowadays.
Okay. Dr. Subramanian, there's one question which is related to the commercial vehicle segment, and this is more on the air compressor that we were initially talking about. So the question is, can we replace compressed air cylinders used for the air braking from metal to type 3 or type 4 cylinders using composites?
Yeah, I mean, that's what's happened with hydrogen tanks, right? There was a type 1, which was made of steel, and now it's type 4, which is carbon fiber composite. Sometimes you have a stainless steel liner for the diffusion barrier. So yes, but at the right cost.
There's another question, wherein the gentleman is saying that, they've already replaced 5 aluminum parts in a truck to engineering plastics. And, those parts are air inlet ducts, thermostat covers, manifold covers. So he's just wanting to check about what are the other possible opportunities to shift from, the conventional aluminum to engineering plastics.
Question is for whom?
This towards you.
I think this requires a detailed discussion. I don't want to give an ad hoc reply to this.
Okay. Sure.
But yeah. But if I may, let me throw out maybe a question to the panelists and also to the audience. See, we are interested in lightweighting technologies that will give us a giant leap in weight reduction. Right. So our internal target, as crazy as that sounds, is like a 50% weight reduction in the gross vehicle weight. Why? Because why are we setting ourselves a target like this? Because all of the ideas we're getting are all incremental ideas, which are doing like 3% or 2% or 5% at the most. I'm not saying it's wrong, but it's all incremental stuff. I'm just not seeing lightweighting ideas which are game changers, which are disruptive, right? So it's more of a challenge. I know there are no answers today, perhaps, but please approach us. We'd love to work with you. If you have ideas, better still if you have proof of concepts which show dramatic weight reduction. Right? I think that may answer a few of the questions which I'm seeing on the Q&A box. But that's really what we need in India at the moment. We don't want to think incrementally along this topic.
Right. I think that is a good target for all the the supplier side attendees in the in the webinar today, particularly I think Mrs. Sudhir Sridhar who had posted this question. So maybe you could come up with a proof of concept that that shows a significant weight reduction and take it to Dr. Subramaniam for him to evaluate.
And when I pose a target like 50%, I think it will spawn a very different set of ideas.
Yeah.
And if the target is 5%, the ideas that we get will be very different.
Right. Right.
Maybe you should not have any cost constraint on this then. Otherwise, it may not be possible.
It's going back to what we were talking about earlier, and I think it's a great challenge to put out there. If you're going to be looking at a blue sky ideas like that, you've got to be willing to say, right, my facility is not going to be fit for purpose, and guys, really, let's rethink this. How are we going to fundamentally change the way that we build a commercial vehicle at the moment? I think it's a really great challenge. It's a great challenge to throw out there. And you're absolutely right. We all, I've been in the industry 40 years, and the easy route to think of is incremental, bite by bite by bite, to keep trying changing things. It's the brave person who actually says, right, let's fundamentally rethink.
So the vehicle is the sum of its parts, and that's why when you do these small little incremental changes and incremental reductions in weight, so you end up getting the overall reduction in the weight of the entire vehicle. Like in Maruti's case, yesterday we saw this example, and even Rao-san just mentioned that today. The Swift, when it was first launched and to now the fourth generation, between the last 2 decades, they've been able to reduce the weight by a substantial 100 kilos. That is a bit of a, it's a very impressive feat that the engineers have been able to achieve. So on that note, we've completely run out of time, and I really appreciate each one of your time, you taking out the time and joining us here and giving your lovely, insightful comments. And I'm sure our audience would have a lot of takeaways from this. I really appreciate everyone joining in. Thank you so much.
Thank you. Thank
Thank you. That's fantastic.
Thank you.
Thank you to my fellow panelists. Thank you.
Thank you.
Thank you all.
So much. Bye.
And with that, we'd like to move to the next session, which is a one-on-one interview. And I'd like to hand it over to my colleague, Prerna Lidu. Prerna, over to you, please.
Hi, thank you, Mayank, for hosting such insightful sessions both yesterday and today. This is, of course, the last session for the day, but nevertheless, not the least. We have with us Mr. Kinshuk Roy today, who's a seasoned steel industry professional with rich experience over 3 decades at establishments like Esser Steel and Tata Steel. And now, after 16 years with JSW Steel, he is the Executive Vice President, Application Engineering and New Business Development at the company. Kinshuk has been at the forefront of driving innovation and sustainable growth within the steel industry, which of course has long been the backbone of automotive manufacturing. From chassis to body frame to engine components, steel plays a critical role in shaping the performance and longevity of automobiles. To explore the role it will play in shaping the vehicles of tomorrow, Kinshuk joins us at the Autocar Professional Vehicle Lightweighting Conference for an exclusive interactive session on the topic Assessing Lightweighting and Environmental Impact with Steel. Welcome, sir.
Good evening, Prerna.
Good evening. Before we begin, I would like to inform our viewers that you can catch the live stream of our sessions on our social media channels, including our YouTube and LinkedIn platforms. Please keep sending your questions and we'll take it up at the end of the discussion. Sir, coming back to you, can you give me an overall brief view, a kind of a context setting, a bird's eye view of why is this issue, lightweighting in automotive, especially when it comes to steel, such a big deal today now more than ever? Obviously, sustainability is a big angle. Cost effectiveness is a big concern. So, can you give me a brief context on why is it so important in today's day and age?
Yeah, thanks, Prerna. Lightweighting has been an essential aspect of vehicle design over, I would say, more than a decade now, and will further gain huge importance going forward. Now, with the latest transition in mobility space as a whole, the future will be defined by EVs, as we all know, and I believe all the esteemed attendees to this conference are experts in this field. And also the autonomous vehicle concept coming in, while it may take a little bit of more time in India to catch it up, but this is the future. Now, with this happening, there will be a pressing need to use advanced lightweight material, first of all, in auto, for three counts mainly. That is to improve driving dynamics, vehicle range for EVs, and some amount of IC engine and hybrid vehicle, which will be there. Hybrid, of course, is one of a very emerging thing in terms of reducing tailpipe emissions in the use phase of the vehicle. So lightweight vehicle structures are essential not only for improving the fuel economy of internal combustion engine automobile, but also increasing the driving range of electric vehicle by offsetting the weight of power systems like batteries. So this will be the context mainly. And steel is a wonder material, as we all say, particularly maybe it may be a little biased for myself saying so, being from the
For
steel
you,
industry.
it's a wonder material for sure.
Yeah, but I will add on to this. Why are we calling it a wonder material? From a lightweighting perspective, as we make it thinner, steel is such a material which retains its strength for vehicle structure and performance and safety. While thinner material means less material going as an input, thereby contributing to mass reduction. But at the same time, it maintains all the characteristics which steel has in terms of strength, ductility, impact considerations, fatigue considerations. And in this aspect, the high strength and the advanced high strength steel, as we say, the industry terms high strength and advanced high strength steel in terms of the strength levels, ballpark, while there are many definitions, but broadly it is on the strength levels. So these steels have the characteristic of being made thinner, still retaining its strength, thereby contributing to lightweight. Now, this is the context. So if we now add the sustainability part to this, that also is an interesting angle. The interesting angle is that the most fundamental aspect of vehicle lightweighting is to consider carbon benefit that the lightweighting will have during the use phase of the vehicle and comparing it with the emission impact of the materials being used for considering the reduced mass action across the entire life cycle. It means that it is not only the use phase, while those materials are being manufactured, how much they emit or what kind of energy they consume. And at the end of the life cycle of the vehicle, what is the recyclability of that material without losing on its characteristics? So I believe this is the context on which advanced high strength and high strength steel gains its relevance.
But are there any challenges on the recyclability front, like you mentioned, in India today specifically?
See, here I would say the challenge, I would believe the government has taken the first step towards it by putting in vehicle scrapping. See, main thing was the vehicle scrapping policy in India was not there, but otherwise processing those scrap and bringing and logistics and the supply chain of that development will automatically happen once the vehicle scrapping is in place. So I believe that towards that direction, lot of step has already been taken, and over going forward, this will be further improving on. And from that angle, we will soon be seeing more vehicles getting scrapped. I mean, if it is implemented all across, and the usage of those scrap by the steel mill will definitely contribute to that.
Yeah, you spoke about electrification. It's true that the automotive industry is transitioning towards more autonomous, electric, and connected vehicles. There is the role of the steel will also be changing going forward. Are there any particular trends pertaining to that you see in the future?
See, here again, I will a little touch upon as to what is happening. I mean, autonomous vehicle concept will take some more time to come to India, while the adoption of EV has taken a very fast pace, and we are seeing lots of EV vehicles coming up. Now, the future of mobility is changing quite rapidly and in a big way. So, what is happening is, I believe, experts must have already spoken about it. Powertrains are becoming more efficient, contributing to the reduction of life cycle CO2. As a result, the impact that mass reduction will have on the reduction of the full vehicle carbon footprint, full EV vehicle carbon footprint, will not have that much of significance. But what will have significance is reducing the weight of an EV will enable the battery capacity to improve. As a result, the range will improve. This means that there will be little reduction in CO2 emission due to lightweighting because EV will not be having emission. So what will lightweighting contribute? Lightweighting will contribute to having more range. That means if the vehicle is lighter, the battery efficiency will go up. So here what will become important is again the entire life cycle. That is when the vehicle is getting scrapped and the lightweighting material that are being used, the production phase of those material, if that is more energy intensive, then the impact of that will not be much on carbon footprint. Here, steel will again play a major role because the end of life cycle, scrapping and using it again is far more than the competing lightweighting material in terms of the energy those lightweighting material require in its production phase. So that is what is the trend catching up as we see going forward.
And things are improving from a scrappage point of view, in your opinion?
I would say that it has started improving because scrappage is something which is new in the country. So definitely it has started improving.
Right. You spoke of these new manufacturing methods. There's also like methods like hot stamping, hydroforming that are sort of being adopted now in the industry. How do you compare these two traditional manufacturing processes in terms of environmental impact?
Yes, Prerna. While these are processes for forming steel to produce parts and being quite particularly relevant for using high strength and advanced high strength steel as an input material. That is, if I have to make a part with high strength steel, so as the strength of the steel goes up, the formability and several other challenges come across. So therefore, certain processes have been developed which complement the use of high strength steel in forming parts. So these two processes which you have, manufacturing process which you referred, are processes which aid the processing of advanced high strength steel and high strength steel. I will very short touch on the hot stamping process.
Sure.
The hot stamping process, typically these are carbon manganese boron alloyed steels. Now, these are also termed or also known as press hardened steel in some part of the world. And in general, it is also called hot stamping. So these steels are used where it is difficult to process or form other high strength steel because of certain challenges of the part geometry and the part complexity. So what happens here is it combines the process of forming and the achieving strength in such a way that the complicated parts can be formed. So what it is done is the steel is heated to a temperature of about 850 degrees centigrade, where it is completely austerized, and then a final shape is made through water-cooled dies that control the rate of cooling and the final strength. So you can make the part and the strength is also achieved. So the high temperature combined with the rapid cooling transforms the microstructure to the desired level of what we call in metallurgical parlance as martensite, giving very high finished, high ultimate tensile strength to the material, which is almost 3 times the strength of the material from the base material from which the steel is made. So normally these parts are used where part stiffness and low deformation are important. That is, which maintains the integrity of the cabin. Say, for example, components like A pillar, B pillar, this kind of components are tried out from them. But of late, various other components have also been developed through the press hardened process. But this process also comes with some challenges. So the challenges of these are, this is an energy intensive process. So as a result, it will pose a challenge to the carbon footprint also. But then, while this will pose a challenge, the good news is that what I spoke just a few minutes before on the end of life cycle recyclability, if we consider the whole and we get the credits, carbon credits for one process and consider all the processes together, then definitely this can be press hardened steel will gain popularity for usage going forward. But yes, the energy input is definitely one challenge which has to be adjusted on the overall life cycle.
So you're saying overall in the long term it's more beneficial, right?
Considering that overall life cycle of the vehicle, manufacturing, use, and the end of life cycle, it is definite, and it aids in the forming of parts where very high strength going forward can be made.
Got it. And what is the impact on the cost per se in terms of is it more expensive? What is the impact on the cost structure like?
Prerna, cost wise, again, it will have to be worked out. It will have a cost impact onto that. But then it has to be considered on the complexity of the part, on the kind of strength, on the kind of overall automotive value that needs to be realized out of using that steel from that context.
So how far have we come from the traditional manufacturing processes in terms of, you were talking about these new manufacturing methods. So is that like really impactful? How far are we from in terms of technology and processes?
See, press hardening again is a process which is used at the automotive end, and there again some automotive have already put in that, and even in our country, a lot of press hardened part is produced, and we are supplying. We do supply steel for press hardened steel, so that is catching up. But then there are certain requirements with the press hardened steel in terms of press hardened steel with coating, which are getting developed, which have not been developed till now, but in the process of developing. So definitely, see, the kind of steel which is getting used in automotive now, we have progressed a lot from the conventional steel towards the new methods. I mean, these are just two methods, but there are even other steel like martensitic steel, which are being produced by the steel, which are inherently strong steel, of course, with challenges of welding or challenges of springback, which are being addressed on. Yeah. But yes, I mean, this advanced high strength steel cannot be, all variety of steel cannot be just made only by the conventional process. It has to come out. And today in India, I believe, while the automakers are here, we are moving fast towards increasing proportion of high strength steel usages. I mean, while I may be approximate, but already 15 to 20%, somewhere between 15 to 20% is already being used, and going forward, this will be further increased in the automotive use, in the total automotive steel usage, the proportion of high strength and advanced high strength steel.
Very interesting. What do you think are the challenges going forward? We are at a very pivotal junction because obviously regulation is also changing and a lot of new material science is coming up. So what are the challenges in terms of material selection, tech, production, processes, if you can highlight some of these?
You mean challenges with respect to?
production processes and even the new technologies coming in for engineers like you, people of the industry who are seeing this change happen?
See, Prerna, challenges with respect to material selection. I believe designers and auto R&D engineers would be able to bring in more insights.
Sure.
However, from a steel perspective, I would say the focus areas will be to further improve upon the challenges in high strength and advanced high strength steel. As I said, some areas like spring back mitigation, weldability, and making availability, I mean, increasing the capability to produce such steel in the country, which has already taken place. And I would say I can take the pride and privilege of saying that JSW Steel has been one of the pioneering steel company, having put the facilities to produce uh, the high strength steel and advanced high strength steel ahead of all in the country. Today we have a gamut of steel which we can produce. Now, further improvement in the existing process and new technologies towards keeping in view the carbon footprint, that is going to be a key focus area. Another challenge, which I mean, overall, I feel again what I have said before, would be to drive the concept of LCA through regulation and government intervention on the one hand, and intensive technical involvement with the OEMs in the automotive industry in establishing the significance of life cycle consideration for overall carbon footprint improvement on the other. So this, I feel, are something on which if we work on, we can progress.
Some experts suggest that there's also a combination of other materials with steel, like magnesium, aluminium, which is also gaining a lot of traction in this country. And India is sort of becoming independent in terms of R&D and even execution in that respect. Would you want to touch upon that? How would that change the industry?
Yeah, very briefly, it's quite some time that multi-material design had emerged as an optimized material selection approach. However, as it stands on date, there are again, since with multi-material approach, there are multi-dimensional factors also, which are impacting the combination of steel with other metals being discussed. Those being the go green factor in combination, emergence of EV, autonomous vehicle mobility as a service, where lightweighting will not just be confined to reducing the use phase challenges, but also overall efficiency improvement. So, so the magnesium or the whatever you have said, it has to be looked into on an overall efficiency improvement, selection of material in such a way that the impact of energy inputs during the manufacturing process and the recyclability factors are considered. So this will definitely be, along with the multi-material thing, this will go together with it as we see it.
Right. And overall, what steps could industry take? Yeah, like you very explicitly mentioned that JSW has been a pioneer in getting certain technologies and working on that. So, what are the other, roadblocks that the industry is facing, and what are the steps that they can take to ensure there is sustainability throughout the life cycle of the products?
See, I think during the course of discussion with you, we have touched on all the points. As such, I don't see that there are any roadblocks. What is there is to take the initiatives forward. As I said, scrapping, as I said, um, uh, interaction with the OEM. For example, I represent uh, my company in the World Auto Steel Forum. So when we interact there, we find that in the West, the concept of LCA has already been included in the regulation. So there, when a decision is taken about a material, this is first being considered. So, so all these things, if uh, uh, being implemented here, I don't see roadblock because a lot of initiatives have already been taken. It may so happen that it will take some time for all of that to mature so that we we realize the value out of it.
Got it. Any other global success stories that could trickle down to India eventually that you can mention? That would be very interesting.
See, global success story in terms of autonomous systems, improvement in the improvement in the IT and the technology side is also one of the things which will catch up in India also in line with the global story, so that the autonomous things gain success. And second will be the mobility as a service provider. This thing is already catching up, which will, today we only have the Olas and Ubers over here, but more such things will come up in India. So what I see is further technology improvement in terms of material technology, in terms of uh, software, electronics onto that field, and the overall infrastructure development in the country with respect to what we are talking today in the battery infrastructure, the charging infrastructure, all those things development will boost the entire thing forward.
Yeah. And is localization a talent? Is localization like a big challenge today in terms of technology, or are we still dependent on different global stakeholders? Will that sort of be something that industry stakeholders will look at in the future?
I believe all the major auto OEMs have, yes, that is a challenge, but I believe all the major auto OEMs and the steel mills together have put great thrust on localization, and today localization in the country is going on in full swing. And as a result of that, in fact, the government has also put in a lot of thrust towards that, and the auto OEMs themselves have come forward in localization, uh, forming uh, closer interaction with the steel mills through various initiatives, parallelly through various value engineering initiatives also. A lot of developments within the country has happened. And yes, I would again say that localization was a challenge, but it has been taken in a big way. And over the last few years, there has been lot of a lot of progress towards the same, and yet more initiatives are ongoing towards increasing the percentage localization with all the major OEMs.
Very interesting. In the same light, we just got a audience question from a gentleman called Mahesh. He's asking, by when can we expect India became independent for AHSS ultra high strength steel and advanced high strength steel? Your answer, sir.
See, my answer will be, see, advanced high strength steel and high strength steel. This is a family of steel. Already, lot of variety of steel are available now with the given capabilities. But going forward, I would say it will be in this is an ongoing research, so it will not happen that it will keep on, it will get exhausted. But I would say all the variety of steel that are now a part of bill of material of vehicle will almost 80 to 85% or slightly more are already available in the country. The rest, I see that a ballpark in next 3 to 5 years, almost everything which are currently declared to be used in the design will be available in the country.
Okay. There is another question. Will composite material replace sheet metal requirements to higher percentage, having more strength? The same question that we discussed, that will
Yeah, we discussed.
combination of, yeah.
See, apparently it may look like that those are having high strength, but then with the carbon footprint, the life cycle analysis, all these things becoming more intensive, we need to, I would say that it will, cannot make a judgment at this point of time, because it will be more tilted towards use of steel, being the major material. And I believe this is the view which is shared not only by us as a steel mill, even the automakers will be sharing the same view, because it may be used, but then the cost and the techno-economic relevance of that will also be important. For example, if only it becomes relevant for about 2% or 3% of the total automotive vehicle, so that way I believe will be.
So volume is always a challenge. Scale is always a challenge, right?
Yeah, because over what production level you feel that you get the same value out of another wonder material at much lower cost.
Yeah, that is the conundrum that all of you sort of deal with on a daily basis.
And over the life cycle, and this LCA thing is going to, I'm saying it has already caught up in Europe and US, and very soon the same thing will catch up in India too.
Okay. Mr. Shailesh Bhagwat is asking, what is the current usage of green steel as EAF or blast furnace? Can you throw some light?
See, blast, here I would say like this, blast furnace is an iron making process. So the iron, we first make iron from the blast furnace, and then we convert iron into steel, whereas EAF is a fully steel making process. Now, going forward, what we do is when we get the iron out of steel, we make steel through the basic oxygen furnace. Now, already lot of improvement measures in the existing blast furnaces are happening to reduce the emission. And going forward, technologies are being developed to further bring down the impact of the emission from these furnaces. But yes, electric arc furnace is also a route which all the steel mills are looking into for making as an option for producing, increasing the green content of it by where you can melt scrap and make green content. But these two are not, I mean, we should not be comparing, because blast furnace is for a very large volume of iron production, whereas EAF or electric arc furnace are are much lower capacity for producing steel only. But yes, they are these electric arc furnace is a method to produce steel with much lower carbon footprint.
There's another, you were talking about including more green in the steel and green steel. We have another similar question on the same lines. What is the Indian steel mill strategy for, things like green steel and sustainability in the steel industry? We briefly touched about it, but what is at a strategy level, how can the industry go forward?
First of all, I would just take 2 minutes to say, I mean, everyone is aware of it, but still for repetition's sake, I will say green steel is actually the process and the production method through which we produce steel. It is not any grade of steel, as we say, high strength steel, advanced high strength steel, low carbon steel, green steel. It is not that. Green steel is the methodology of production of steel with lower carbon footprint as much as possible. So now to answer the question, the thing is, yes, already steps are being taken in various phases. So since already huge production lines are already in operation, so bucket one is that various improvement measures are being taken to reduce the emissions and to increase the scrap usage, all such things in the existing furnace, so that the carbon footprint improves. And second is, over a period of time, to bring in new technologies. One very, though it is not a new technology, but it is better than the EAF question which has been asked, but further emerging new technologies or methods to produce steel, where as such the emission or the carbon footprint will be less. Now, this will happen over a period of time. Now, till that is happening, there is various certifications are being done, where certifying bodies are coming and auditing the processes, and they are judging it that if there was carbon footprint X, how much it has reduced. So to that extent, it is green. So that way, certifications are being used for volumes of steel. And this will continue for some time, while parallelly technologies will be, emerging technologies will come and completely make it to the extent, I mean, whatever can be defined as green steel. So this is going to be the strategy going forward. So it will be over a period of time, say, targets up to 2035, 2040, 2050, till the time it is totally carbon free.
Very interesting. We are already running out of time, but I would want to take just one last question. What about the lightweight steel like ferritic steel? Any work going on reducing an existing weight of the steel component? Srinivasan Dhanraj asks this question.
Ferritic steel.
Ferritic, FEAL.
Okay, I probably
So
get
it's basically about efforts being done on on reducing the existing weight of steel.
No, I would say that several initiatives are being done on reducing the existing weight. Ferritic steel, if I have understood the question, maybe is a grade of steel, is a type of steel production. Yes, lot of efforts within the country or R&D efforts are there in developing this, though this is not in very big way mass production, but yes, developments are onto this.
Sure. Thank you so much, Mr. Roy. It was great having you today, and would want to continue this conversation with you offline as well. And for our other sessions, would love to have your insights for our other sessions as well and other events. Thank you so much for your time. And I would now want to hand it over to Mayank Dhingra, who would give his closing remarks on the session. Thank you.
Thank you, Prerna.
Thank you so much, Mr. Roy, for joining us. And thank you, Prerna, for that lovely fireside conversation with Mr. Roy and detailing about the various aspects of steel and how it is contributing towards lightweighting and overall sustainability. So really appreciate your time and for moderating the session.
Thank you.
And with that, we come to the close of the two-day Autocar Professional Vehicle Lightweighting Conference. I really want to thank everyone who logged in of the last 2 days, yesterday and today. We really hope that you had a lot of key insights from this conference, which is our annual initiative, and we will continue to bring it in the coming years as well. The recordings of both the sessions could be found on the Autocar Professional YouTube channel, as well as on our LinkedIn site as well. So whatever you want to go back to refer, you could just log into our YouTube channel, and this would be published there for your future reference. And we really hope that you enjoyed joining for both the days, and do keep sending us your feedback, and so that we could make this initiative better going forward. Once again, thank you so much all for joining, and until next time, take care. Goodbye.